2014 MCAS number 9, and it asks which of the following equations represents a linear function. So A has a basic function y equals x squared, which is that parabola. That's not a linear function. B, the basic function there, is y equals 1 over x, which looks something like that. That's a transformation of it. C, the basic function is square root of x, and then it's translated 6 up. And then D, the basic function is y equals x, but this is also a linear function. We can recognize it looks like y equals ax plus b. Another great strategy for this problem, if you're not sure which is a linear function, is to pick 3 or 4 points on each graph them, and see which ones fall in a straight line. Because untimed, that's not a problem. Pick easy values. So, for example, for C, if we were going to make a table, you could pick x values of 4, 9, 16, and 25, just so taking the square root was quick. So 2 plus 6 is 8, 3 plus 6 is 9, 4 plus 6 is 10, and 5 plus 6 is 11. And there you can see that the slope is definitely not the same, because the change in y over the change in x is not constant, because the change in y is constant, and the change in x is not constant. This is number 12 on the 2014 MCAS, and we're asked which expression could be used to calculate the temperature of the liquid after m minutes. So we can see on the graph that after 0 minutes the temperature is 40, which means that B and C are eliminated because both of those have an initial value of negative 40. And then we can figure out the slope of the graph. So if we pick 2 points on the graph and we do rise over run, we can see here that we go up 40 and to the right 8. So we have a change in temperature of 40 degrees Fahrenheit over 8 minutes, which is a slope of 5. So we have option A. This is problem number 13 off 2014 MCAS. So for this problem, they made guess and check a little bit more complicated, because instead of giving you the weights for a red block and a green block for the choices, they gave you the weights for one red and one green combined. You actually could still use guess and check, but I think probably for most students the more straightforward approach is going to be elimination, so I'm just going to do that. So we end up with 2 equations from the problem, because we know if we say that R is the weight of a red block and G is the weight of a green block, then we know that twice the weight of a red block plus 6 times the weight of a green block is equal to 23, and then we also know that 3 times the weight of a red block plus 4 times the weight of a green block is equal to 22. So at this point, combining the equations isn't going to help us, because none of the variables are going to be eliminated. But if we were to multiply the top equation by negative 3 and the bottom equation by 2, and you'll see why in a second. So the top equation becomes negative 6r minus 18g is equal to negative 69, and the bottom equation becomes 6r plus 8g is equal to 44. And remember that multiplying both sides of an equation is a basic move and doesn't change the solutions for that equation, so we're allowed to do that. And now, if we add the left side of the second equation to the left side of the first one, the r values cancel out. So we end up with negative 10g, and the right side to the right side, we get negative 25. So because 6r plus 8g is equal to 44, I can add 1 to one side and 1 to the other, and it's basically adding the same thing to both sides. This tells us that g is equal to 25 over 10. If we simplify that, we get 5 halves. We can then go back to either of the original equations. They both look relatively complicated. I'll just use the second one in this case to find r. So over here we're going to say 3 times r plus 4 times 5 halves is equal to 22. 3r plus 10 equals 22. That means 3r is 12, which means r is 4. And then it asks us what is the weight of 1 red block plus 1 green block. So that would be 2.5 plus 4, which is 6.5. This is number 15 off the 2014 MCAS. The key for this problem is really just being careful. My guess is a lot of students on this problem are going to put that the rate of change is 10 miles for every gallon of gas used, because they're going to try to look down here at the bottom part of the graph, down here, and they're just going to estimate that it goes through the point 1, 10, which the graph doesn't. So the key is using this other information that they gave you, and so when we get the rate of change, we're really going up 60 and to the right 5, so 60 miles per 5 gallons, and if we simplify that, we get 12 miles per gallon, and that is option B. This is number 17 off of the 2014 MCAS. This is a concept you just want to know. You just can review it for about 10 minutes and you'll probably be fine with it, but it's shown up on all of the MCASs for the last 3 years, and it's almost certainly going to show up on the 2015 MCAS. They give you an equation, and you have to determine if it has no solution, one solution, in this case 2 solutions, which is impossible because it's a linear equation and they can't cross exactly twice, or infinitely many solutions. So I'm going to rewrite the equation as, with the distributive property on the left, 6 minus 3k is equal to negative 3k plus 2. And immediately we can see the negative 3k's on both sides are the same, and it would never be possible to have 2 equal to 6. So this equation has no solution. You would have ended up with infinitely many solutions if you had something like 5 minus 3k equals negative 3k plus 5, because then the sides are the same no matter what value k is, and to have exactly one solution, you would have to have the coefficients of k different on the 2 sides, because you wouldn't want them to cancel out. If the variables cancel out in the equation, you're either going to have no solutions or infinitely many solutions. So here's another rate problem, and they give you a graph in this case, and they say, what is the unit rate for the cost of a salad at the salad bar? So they give you these 2 points on the graph, 0, 0, and 1/2, 2. So we can figure out the rate in this case as 2 minus 0, and that's a difference in the cost, over 1/2 minus 0, which is 2 over 1/2. And if we want per pound, right now we have per half pound, we could multiply by 2 over 2, which is a form of 1, and then we get $4 per 1 pound, because 1/2 times 2 is 1 pound. So that is option D.